Imagine stepping into your shower, but it's a bathroom where you are fundamentally locked out of the plumbing.
Right.
Like, you aren't allowed to touch the pipes at all.
No access whatsoever.
Now imagine that the walls around you are literally sweating out limestone to, you know, heal their own microscopic cracks.
Which is just a wild concept to even visualize.
It really is. And just outside the door, you have 12 different robots machines
Yes.
that know exactly what you eat, when you sleep, how you move, and they are quietly running the absolute entirety of your domestic life.
Every single chore.
Welcome to today's deep dive. We are incredibly glad you could join us today.
Yeah, thanks for being here.
We have a mission today that feels like it's pulled straight out of, I don't know, a cyberpunk science fiction novel,
Oh, absolutely.
but it is entirely rooted in a very real, very audacious document from March 2026. We are unpacking a highly detailed business prospectus for a proposed tech startup called GlobalProp AI.
And just to give you a sense of the sheer scale we are dealing with today, this isn't some theoretical white paper floating around a university architecture department.
Right, this is a business pitch.
Exactly. This is a granular, highly specific blueprint that was pitched directly to billionaire Mark Cuban.
On Twitter, no less.
Right, on Twitter by an entrepreneur and sci-fi author named Paramendra Kumar Bhagat.
Which kind of explains the sci-fi angle of the whole thing.
It really does. It is this fascinating, almost overwhelming collision of venture capital ambition, advanced material science, and honestly futuristic world building.
All aimed at a $1 trillion valuation.
A trillion with a T.
Okay, let's unpack this, because the scale of the ambition here is what immediately grabs you.
It's massive.
This document attempts to completely dismantle and redefine what a house actually is. It proposes what the founder calls the robot-optimized home.
Which is a very deliberate choice of words.
We are talking about a dwelling where every single chore is outsourced to machines. Your everyday appliances are physically sealed behind the walls, and the building materials themselves are, well, alive.
Literally biological.
And the pitch makes the staggering claim that by deploying this specific architecture, they can solve the global housing crisis
Hit that $1 trillion valuation by 2036.
and turn individual homes into the foundational interactive nodes of futuristic smart cities.
Now, before we dive into the physical mechanics of, a self-healing wall or the economics of a $1 trillion housing startup, I think it's crucial to establish the ground rules for you, the listener.
Yes, definitely.
We are exploring this pitch today purely as an intellectual exercise.
We're just looking at the blueprints.
Exactly. We are going to vigorously analyze the claims, the financial modeling, and the underlying science presented in the source text.
But we aren't saying this is definitely going to happen.
Right. To be entirely clear, we are not endorsing the feasibility of this project, nor are we taking sides on any of the underlying socioeconomic or political claims made in the prospectus.
Because there are a lot of them.
A ton of them. We are simply here to deconstruct the mechanics of a truly radical idea and see how the pieces fit together.
Exactly. We're looking at the blueprint. And before we could even begin to understand how a company plans to make $1 trillion in 10 years, we have to look inside the product itself.
The physical house.
Right. What exactly is a robot-optimized home? Because the source text sets up this incredible paradox of physical space.
The 1,500 square foot paradox.
Yeah. They are focusing their entire mass market strategy on a 1,500 square foot prefabricated home.
Which is pretty small.
By modern American standards, that is a relatively modest footprint. But GlobalProp AI claims this 1,500 square foot unit delivers the effective living, working, and entertaining space of a home more than twice its size.
Like a 3,000 plus square foot traditional home.
Right, so if I am looking at a floor plan, how does that math actually work in the physical world? You can't just invent square footage.
Well, it works through dynamic spatial reconfiguration.
Okay, explain that.
It's a fundamental departure from how we have built shelters for the last, 10,000 years.
We build a box and we put smaller boxes inside it.
Exactly. Traditional homes are notoriously inefficient because they rely on static, dedicated spaces.
Like a bedroom that is always a bedroom.
Right. You have a guest bedroom that remains empty for 350 days a year.
Totally.
You have a formal dining room used solely for Thanksgiving and maybe a few dinner parties. You are heating, cooling, and paying a mortgage on trapped, unused air.
That makes sense. So how do they fix that?
GlobalProp AI essentially eliminates the concept of a static room. Instead, the home features robotic movable partitions,
Moving wall.
moving walls, and advanced track systems embedded directly into the ceiling and the subfloor.
Wait, so instead of walking into a different room for a different activity, the room itself morphs around you.
That is precisely the concept, though the execution is highly technical.
So what does that look like on a Tuesday afternoon?
Well, on demand, a single large living area can physically partition itself. A wall glides silently across the room to section off a private office during your workday.
Okay.
And then in the evening, that same partition retracts, and another wall deploys a hidden Murphy-style bed, instantly transforming the space into a primary bedroom or a home theater.
So the architecture adapts to your immediate need.
Exactly. Because activities like sleeping, working, and entertaining happen sequentially rather than simultaneously, you don't need dedicated permanent square footage for each of them.
It's like living inside a giant transforming smartphone.
That's a great analogy.
Depending on what app you open, whether it's the sleep app or the dinner party app, the hardware magically updates to accommodate you.
Yeah, the house boots up the appropriate physical layout.
But, I mean, if the walls are moving and shifting all day, what about the actual labor of maintaining the house? Sweeping under those tracks, cleaning the moving parts?
That brings us to the workforce.
The robots.
The robots. The prospectus is very clear that human labor is entirely removed from the domestic equation.
Which sounds like a dream, honestly.
It does. Every home comes standard with a fleet of 8 to 12 multifunction robots.
12 robots. In a 1,500 square foot house.
Yes. We are talking about a highly coordinated mix of humanoid robots designed for varied terrain and specialized robotic arms integrated into the architecture itself.
And they do what exactly? Vacuuming.
Much more than vacuuming. They handle 100% of the household chores.
100%.
The text specifically lists cleaning, laundry, cooking, grocery stocking, and even structural repair.
Structural repairs.
Yes, it is fully delegated to the machine ecosystem.
Okay, here's where it gets really interesting. And honestly, it took me a minute to wrap my head around this when I was reviewing our notes.
The zero human access part.
Yes. The text introduces this concept called zero human access appliances.
Which is wild.
They are proposing a radical design where the major appliances, the refrigerator, the oven, the dishwasher, the washing machine, are fully embedded behind seamless walls or ceiling panels.
Completely hidden.
Humans are physically blocked from interacting with them.
This is where the pitch moves from just automation to total ecosystem control.
I mean, I can't even open my own fridge.
You do not open a refrigerator door to browse for a snack. You do not load dirty plates into a dishwasher, and you certainly never pull hot laundry out of a dryer.
So how do you eat? If I want a cold drink at 2 in the morning, what happens? I just stand by a blank wall.
You request it via the home's AI interface?
Like talking to a smart speaker.
Yeah, or a visual interface, because behind those seamless walls, you have a sterile, optimized utility corridor.
Like a hidden hallway for machines.
Exactly. The robotic arms we mentioned earlier operate within these hidden spaces.
Okay.
An internal gantry system retrieves the drink from the thermal cooling unit and delivers it to you through a small automated service hatch that briefly opens in the living space.
Like a dumbwaiter, but run by AI.
Basically. And when the system cooks a meal, the robotic arms gather the ingredients from the sealed cold storage, transfer them to the sealed induction heating units, plate the food, and present the finished meal.
So I just order dinner from my own house.
You never see the raw ingredients, and you never see the heating element.
It sounds incredibly sleek, but also entirely dependent on absolute perfection.
Which is a massive caveat.
Right. I have to push back here, because this is where the theory of a robot-optimized home collides with the chaotic reality of human life.
Human error is the ultimate variable.
Exactly. What happens when a toddler leaves a solid plastic toy in the recessed floor track of a moving robotic wall?
Yeah, that's the nightmare scenario.
Or worse, what if the home brain, this central and edge AI system that supposedly monitors everything and runs over-the-air software updates, decides to reboot while I'm in the middle of a zero human access shower?
You're just stuck.
Am I just trapped in a dark transforming box with no way to turn the water off?
What's fascinating here is that you are pointing out the exact friction points of treating a biological human habitat like a data center server rack.
It just seems so fragile.
Up until now, we have lived with passive smart homes.
Right, like Philips Hue bulbs or whatever?
Yeah, you ask a smart speaker to turn on a light or you program a thermostat from your phone, but at the end of the day, you are still the manager of the home.
I can always go flip the physical switch.
Exactly. You are the ultimate failsafe. GlobalProp AI is proposing an active robotic ecosystem.
Meaning the house is the manager.
In this new paradigm, the home is the manager. It observes you. The prospectus treats the human inhabitants almost as VIP guests in a fully automated, ultra-luxury hotel that happens to be operated by the physical structure itself.
So the house is supposed to be smart enough to not crush the toddler's toy.
That is the promise. The source text leans incredibly heavily on predictive safety.
How does it predict a toy on the floor?
The home brain relies on an array of sensors, lidar, thermal imaging, acoustic monitoring to execute continuous spatial awareness.
So it sees everything all the time.
It includes advanced fall detection and intruder response protocols. The implication is that the AI is running at a frame rate high enough to instantly halt a multi-ton moving wall if it detects an anomalous object in the track.
Whether that's a plastic toy or a pet.
Right. Furthermore, for a life safety system like a shower or a moving partition, the architecture would mathematically require localized, hard-coded edge computing.
Meaning it doesn't need the internet to know not to crush you.
Exactly. It cannot be taken offline by a routine cloud update, but your skepticism is valid.
It's a huge psychological leap.
The psychological leap required to surrender your physical safety and your basic daily necessities to an automated system is massive.
And it extends to the utilities, too. If humans aren't touching the appliances, they certainly aren't fixing the plumbing.
No, absolutely not.
The text describes this centralized robotic utility core. They claim that instead of traditional rigid pipes snaking through every wall, the plumbing uses modular, quick-swap pipe segments.
Like Lego bricks.
Yeah, that can be swapped out by the maintenance bots in minutes.
And the HVAC doesn't use massive central ductwork. It uses AI-optimized microzones.
And the electrical system relies heavily on inductive and wireless charging integrated into the surfaces.
Which is how they arrive at one of their most aggressive economic claims.
The cost savings.
By minimizing fixed, rigid infrastructure, eliminating the need to tear out drywall to fix a leaking copper pipe, they allege they can cut capital expenditures and long-term operating costs by 50 to 70%.
That is a massive reduction. But to even build a self-transforming robot-serviced home like this, you can't exactly drive down to the local hardware store and load up a pickup truck with 2x4s and standard gypsum drywall.
Oh, a wood frame would never survive this.
Right. A wooden frame would warp, the tracks would misalign, and the whole transforming illusion would shatter in a month.
It would be a disaster.
This brings us to the actual physical construction of the product.
The alchemy of construction, basically.
Yeah. To understand how they plan to mass produce these homes, we have to examine the specific 2026 material science breakthroughs they are banking on.
We are looking at a fundamental reimagining of what a building material is.
It's not just wood and nails anymore.
Not at all. These materials blur the line between synthetic engineering, aerospace manufacturing, and actual biology.
Biology.
Yes. If we want to understand the durability required for a house that is constantly moving its own interior walls, let's start with the structural integrity.
Okay, let's get into it.
The prospectus highlights a very specific breakthrough from January 2026, pioneered jointly by North Carolina State University and the University of Houston.
Okay, so real-world, peer-reviewed science.
Exactly. They developed an advanced fiber-reinforced polymer composite, or an FRP.
I know FRP is used in industrial applications like pipes or tanks, but they aren't just molding a strong plastic shell here, are they?
Far from it. Standard FRP is strong, but it is brittle over decades of stress.
It cracks eventually.
Right. This specific 2026 composite integrates 3D printed healing agents and microscopic embedded vascular networks.
Vascular. Like veins.
Similar to veins, yes, along with integrated thermal heaters.
Okay, so the plastic has heated veins. Why?
Well, when the material experiences delamination or microcracking from physical stress, like a moving wall shifting over time, the system detects the structural weakness.
Wow.
The embedded heaters activate at the site of the microcrack, melting the 3D printed healing agents.
Oh, wow.
Which then flow into the crack and repolymerize, eponymously repairing the damage.
So the plastic is literally healing its own microfractures.
Exactly. And the source text notes this material can undergo this self-repair cycle over 1,000 times without degrading its core structural properties.
1,000 times. That's incredible.
This composite is engineered to be tougher than the materials currently used in commercial aircraft wings or offshore wind turbine blades.
Which are some of the harshest environments on Earth.
Right. Based on advanced modeling, the founders suggest that with annual autonomous self-repair cycles, these structural components could have a functional lifespan upwards of 500 years.
500 years.
It's staggering to think about.
That completely upends the entire life cycle of real estate.
Hmm.
We're used to 30-year mortgages on homes that need a new roof in 20 years.
And a new water heater in 10.
Exactly. And it doesn't stop with the polymers. They're also proposing the use of self-healing concrete for the foundations and heavy structural elements.
Right, the concrete.
The text specifically name-checks a process called microbially induced calcite precipitation.
This is where we cross firmly into the biological realm you asked about earlier.
Okay, explain this to me because it sounds crazy.
Microbially induced calcite precipitation involves mixing specialized dormant bacteria, typically a strain of bacillus, along with specific organic nutrients directly into the wet concrete mix during the batching phase.
I just have to pause and absorb that. They are intentionally infecting the foundation of the house with bacteria.
They are seeding it, yes.
Painting it, okay.
The bacteria remain entirely dormant while the concrete is solid and dry. They just sleep.
Okay, but concrete naturally develops micro cracks over time
All right.
due to settling or temperature changes?
Exactly. Thermal expansion, load stress, it all causes tiny fissures. When a microcrack forms, environmental moisture rain, humidity, or groundwater inevitably seeps into the fissure.
And that wakes up the bacteria.
That ingress of water is the biological trigger. It wakes up the dormant bacteria.
And what do they do once they wake up? I mean, are they eating the concrete?
No, they begin to consume the embedded nutrients that were mixed in during the bashing phase.
Okay, so they have a food supply.
Yes. As a metabolic byproduct of this consumption, the bacteria excrete calcium carbonate.
Which is essentially limestone.
Exactly.
So my foundation cracks, water gets in, and the house literally sweats out limestone to heal its own wounds and seal the crack shut.
It creates a biomineralized plug that restores the water tightness and structural integrity of the concrete.
Preventing the internal steel rebar from rusting.
It is a brilliant biomimetic engineering solution.
But concrete is heavy, which introduces a problem if you want to manufacture these homes in a central factory and ship them, right?
Right. Shipping concrete is incredibly expensive.
Which brings us to the next material on their list. To counteract the weight of the concrete and the heavy robotics, they are utilizing recycled carbon fiber panels.
Very important detail, the recycled part.
And the text notes these are sourced from aerospace and automotive manufacturing waste.
Which is a crucial detail for the economics. Virgin carbon fiber is prohibitively expensive and incredibly energy-intensive to produce.
You can't build a mass-market home out of brand-new Formula One car parts.
No, you'd be bankrupt before you built the front door. But by capturing the offcuts and end-of-life components from the aerospace sector, they can achieve the exact same strength-to-weight ratio.
But at a fraction of the economic cost.
And a vastly reduced carbon footprint. These panels are 50% lighter than structural steel.
Which feels like a massive logistics play.
It's purely logistical.
If I am trying to build $1 trillion company, I can't be paying exorbitant freight costs to ship heavy steel boxes across the country.
Every pound costs money.
Right. If the module weighs half as much, you can load more units onto a single flatbed, and you can ship them from a centralized gigafactory much faster and cheaper.
But beyond logistics, the low weight has to be critical for the internal mechanics, right?
Oh, absolutely.
If you have robotic walls sliding across the ceiling, you don't want them weighing a ton.
Precisely. The ultralight carbon fiber skins make instant room reconfiguration mechanically viable.
You couldn't do it with drywall.
No. If a wall partition weighs 1,000 pounds, moving it requires massive, noisy, energy-draining industrial motors.
It would sound like a factory floor in your living room.
Right. If the partition is a rigid carbon fiber shell weighing a fraction of that, a low-voltage, silent magnetic track system can glide the wall effortlessly into place.
It changes the entire energy profile of the home.
But let's talk about the shell of the home. The pitch details a construction method using 3D printed insulated concrete forms, or ICF.
Now, 3D printing a house isn't a brand new concept,
No, we've seen startups doing that for a few years now.
but they claim their proprietary method cuts total concrete use by 70% compared to traditional pours.
70%.
And they claim the printer nozzle lays down the structural form, the thermal insulation, and the internal robotic utility channels in one single continuous pass.
So it's not just squirting out gray concrete.
No, it's printing a highly complex, multi-material sandwich. Traditional construction is highly sequential.
You pour a foundation, wait for it to cure.
You frame the walls, then an electrician comes in and drills holes for wires.
Then a plumber comes in and cuts notches for pipes.
And then someone else installs insulation. It takes weeks or months.
It's incredibly labor-intensive.
GlobalProp's 3D printing process is concurrent. As the robotic gantry extrudes the walls, it is simultaneously leaving perfectly mapped, hollow voids.
Like little tunnels inside the walls.
Yes. These voids are the utility corridors we discussed earlier. So when the printing is done, the maintenance bots simply slide the modular plumbing and electrical harnesses into the pre-printed voids.
Like sliding a cartridge into a video game console.
Exactly. The text claims this drops on-site assembly time down to just 3 to 7 days,
3 to 7 days for a complete home.
while delivering a structure with a wind resistance rating of over 250 miles per hour.
Essentially hurricane-proof. And we haven't even touched on the interior finishes yet.
The biomaterials.
Yeah, the source text heavily emphasizes sustainable biomaterials for the living spaces. They're proposing using mycelium, which is the vegetative root structure of fungi,
Mushrooms, basically.
along with hempcrete and biofiber panels. They describe these as living blocks that offer superior humidity control and absolutely zero volatile organic compounds, or VOCs.
No toxic off-gassing like you get with fresh paint or new carpets.
Right. And because it's essentially pressed mushroom roots and hemp, at the end of their life cycle, these interior panels can literally be composted into the earth.
It creates a closed-loop material life cycle for the parts of the house that experience the most aesthetic wear and tear.
So the bones of the house are forever, but the skin is compostable.
You have a 500-year polymer skeleton, a self-healing biological foundation, and compostable interior walls.
It is a radically divergent approach from the toxic glues, synthetic carpets, and unrecyclable drywall that dominate current construction.
It really is.
Okay, I have to jump in here and inject some market reality into this sci-fi utopia.
Fair enough. Let's ground this.
A house that sweats limestone is framed with aerospace-grade recycled carbon fiber, printed by autonomous robots in 3 days, and insulated with compostable mushroom roots.
It sounds expensive.
I hear all of this, and my immediate reaction is this actually realistic for a mass-market home?
That's the billion-dollar question.
Or are we just designing a $10 million tech bro bunker for a billionaire
Yeah.
and pretending it is a scalable solution for global affordable housing?
The economics are exactly where this pitch attempts to pull off its most impressive sleight of hand.
Okay, break it down for me.
On paper, integrating all of these exotic materials and bleeding-edge robotics sounds astronomically expensive.
Right.
However, the prospectus argues two primary counterpoints. First, they point to the zero maintenance budget.
Zero maintenance.
Traditional homes bleed money over decades in upkeep roofs, HVAC failures, pipe leaks, pest damage.
Tell me about it.
By using self-healing materials and predictive robotic maintenance, they theoretically eliminate the lifelong capital drain of homeownership.
So they're arguing total life cycle cost versus upfront sticker price.
Yes. You might pay more upfront, but you never pay for a repairman again.
Okay, I see that. What's the second point?
The second and far more critical argument is the manufacturing methodology. They are proposing a gigafactory model.
Like Tesla.
Exactly like Tesla. They aren't building these homes one by one in a muddy field.
Where weather and labor shortages delay everything.
Right. They are combining these materials in highly automated, climate-controlled environments, similar to automotive assembly lines.
So it's an industrial product, not a real estate project.
The prospectus claims that this proprietary vertically integrated process produces housing modules 68% faster than traditional methods,
The 68%.
which supposedly drives the all-in manufacturing cost down to a staggering $180 to $220 per square foot.
Which is wildly disruptive.
Completely.
The text cites traditional conventional building costs at $300 to $400 plus per square foot. If they can actually print and assemble a home for $200 a square foot, that is a massive margin opportunity.
The economic moat they are attempting to build isn't just the exotic materials themselves, it's the vertical integration of producing and assembling those materials at an unprecedented industrialized scale.
So if we assume for a moment that they can actually pull off this manufacturing miracle, which is a big if, we have to look at the financial engine driving this company.
The business model.
Exactly. How exactly does this transition from a really cool futuristic science project into a $1 trillion corporate valuation in the span of just 10 years?
Let's dive into the trillion-dollar math.
It all begins with the seed ask.
Right, the pitch to Mark Cuban.
The founder, Paramendra Kumar Bhagat, is asking Cuban for an initial investment of $75 million.
Which is priced at a $750 million pre-money valuation.
That's a huge valuation for a company that hasn't built the factory yet.
It's pure venture capital optimism. This specific injection of capital is earmarked solely to build Gigafactory, #1, which they plan to locate in the Dallas-Fort Worth area, or DFW.
And DFW makes a lot of strategic sense if you are trying to launch a heavy manufacturing startup.
Oh, absolutely.
The text notes it's an established manufacturing and logistics hub. It sits in the middle of the country for easier shipping. It's experiencing a massive demographic housing boom.
Everyone is moving to Texas.
Right. And Texas has notoriously pro-business, low-friction regulations. But the factory is just the start. The revenue streams are where the business model gets truly layered.
This is where it stops being a construction company.
Their primary upfront revenue is simply selling the actual homes, which they price between $270,000 and $330,000.
Which is very competitive.
It is. But if you understand the model they are building, the house itself is just the hardware. Selling the physical shelter is merely the customer acquisition strategy.
Right, they want you in the ecosystem.
The recurring revenue is the kicker.
Yeah.
It's the classic razor and blades business model applied to residential real estate.
You buy the cheap razor to keep buying the expensive blades.
Exactly. You buy the $300,000 razor, the physical house, but you are then locked into paying a massive $99 to $299 per month for the AI and robot operating system subscription.
You are paying for the software blades that actually make the house function.
Which introduces a profound dependency.
A scary dependency, if you think about it.
If you live in a house where the appliances are sealed behind the walls and the floor plan only functions if the ceiling motors are active, what happens if your credit card expires?
Or if the Wi-Fi goes down.
Right. If you don't pay the $299 subscription, do your robots go on strike?
Do your zero human access appliances physically lock you out of your own food?
Does your living room refuse to transform into your bedroom? I mean, are you just sleeping on the floor of your office?
The text does not explicitly answer how a subscription default is handled, but the absolute dependency of the user on the software platform is incredibly clear.
And it gets even more intertwined with the financial markets, because there is a tokenization aspect to their revenue model.
The crypto angle.
Yeah, they want to put fractional ownership of these physical homes onto a blockchain ledger, allowing for instant secondary trading.
And the platform GlobalProp AI takes a 0.5% transaction fee on every trade.
I really have to push back hard on this concept. Are we seriously proposing turning family homes into day trading assets on a blockchain?
The prospectus frames tokenization as a mechanism for democratizing real estate.
Democratizing? How?
Well, it creates an instant secondary market and network liquidity. Instead of needing a massive down payment to buy a whole house, someone could theoretically buy a digital token representing a fraction of % of a robot-optimized home.
And earn a yield on it, like a stock dividend.
Exactly.
But doesn't that risk creating insane volatility in where people actually live?
It absolutely introduces market volatility to the concept of shelter.
If a subreddit decides to short my neighborhood, or if an algorithmic trading bot dumps thousands of tokens related to my zip code, does my property value plummet overnight based on internet sentiment?
You could lose your equity in a flash crash.
I mean, how does a blockchain ledger handle the emotional and physical reality of a family shelter?
It doesn't. It is a critical vulnerability in the sociological framework of the pitch.
It's gamifying housing.
You are highlighting the systemic risk of tying residential stability to the hypervolatility of crypto trading mechanisms. From GlobalProp's perspective, they have abstracted the home into a purely financial asset that generates yield through efficiency and data.
And speaking of data, That is their final and perhaps most lucrative revenue stream.
Data is the new oil, as they say.
They plan to license the anonymized AI data generated by these homes to major insurers, urban planners, and retail aggregators.
So the rollout strategy to aggregate all this data and reach that trillion-dollar mark is incredibly aggressive.
What's the timeline?
They have a 10-year roadmap. Phase 1, covering years 1 through 3, is entirely focused on DFW.
The Texas Gigafactory.
Right. They aim to deploy 500 to 1,000 pilot homes to prove the manufacturing and the software.
Okay, a beta test.
Then phase 2, years 4 through 6, is a rapid national expansion targeting California, Florida, and the Midwest, aiming to manufacture 100,000 homes a year.
That's a huge jump.
It is. Finally, phase 3, years 7 to 10, is a massive global expansion targeting Europe, Asia, and Latin America, hitting a production run rate of over 1 million homes a year.
1 million homes a year.
And this rapid scaling timeline underpins their staggering financial projections. They claim year 1 will see $150 million in revenue from those initial pilot sales.
Right.
By year 10, assuming they hit that million home annual run rate and compound their subscription and data revenues, they project over $60 billion in annual revenue.
$60 billion.
To arrive at the $1 trillion valuation they are pitching, they simply apply a 20x multiple to that year 10 revenue.
So what does this all mean for the investor? How do they possibly justify a 20x multiple?
They have to change the narrative of what they are selling.
Traditional construction companies, even the absolute biggest home builders in the world like Lennar or D.R. Horton, do not get valued like that.
No, they don't.
They might trade at 1 or 2 times revenue.
Traditional home builders get valued on their physical land assets, their standing inventory, and their relatively low-margin one-off sales.
Because building houses is hard, slow, physical labor.
The 20x multiple relies entirely on convincing investors to view GlobalProp AI not as a construction company, but as a pure-play tech platform.
Like a software as a service or SaaS company?
Exactly. In the tech sector, high multiples are justified by massive margins and zero marginal cost of replication.
Because software is cheap to copy.
Right, but houses are not.
So how do they bridge that gap? How do they convince a venture capitalist that a concrete house is basically a software subscription?
It hinges on what the text refers to as the data flywheel.
The data flywheel.
Yes. The physical house is essentially a loss leader, or at least a low-margin hardware deployment.
Like selling a PlayStation at a loss to sell the video games.
Precisely. Every single home they deploy acts as a node that continuously gathers sensor data.
From the robots, the walls, the inhabitants.
That data is fed back into the central neural network, which improves the AI algorithms, the robotic efficiency, and the predictive maintenance models for all the other homes on the network.
So the network learns from itself.
The more homes they build, the smarter, more efficient, and more valuable the underlying operating system becomes.
They are telling investors, we aren't selling shelters. We are selling the definitive operating system for human living.
That's the pitch that gets you a $1 trillion valuation.
And the ambition of that operating system doesn't stop at the individual property line.
No, it scales up to the city level.
The pitch explicitly states that these robot-optimized homes are designed to be the atomic units of the broader smart city.
The building blocks of a new urban grid.
Let's zoom out and look at the macro view. How do these individual structures interact with the outside world? Because they are positioning these houses to essentially run the neighborhood's infrastructure.
This is where we introduce the concept of the virtual power plant, or VPP.
Okay, what is a VPP?
We traditionally think of a power plant as a massive, centralized facility burning coal or splitting atoms.
Right, big smokestacks outside of town.
A virtual power plant decentralizes that. These homes are designed to automatically balance the load of the municipal electrical grid.
How does a house balance a grid?
Each home captures solar energy and stores it in robotic-managed battery arrays. The home brain uses predictive AI to know exactly how much power the home will need for the next 48 hours.
Because it knows my schedule, when I cook, when I sleep.
Exactly. If it has a surplus, it automatically trades that excess power back onto the city's smart grid via a blockchain smart contract.
So my house is basically day trading electricity while I am at work.
It's buying low and selling high on the energy market, yes.
That is wild.
And because millions of these homes are perfectly coordinated by the central AI, they can collectively release power during peak usage hours.
Like a hot summer afternoon when everyone's air conditioning kicks on and the grid is straining.
Or they can absorb power when the grid is overgenerating, like during a super sunny, windy morning. The text claims this VPP capability could potentially cut peak urban power loads by 20 to 30%.
which is huge for municipalities.
It completely eliminates the need for cities to build expensive, highly polluting new peaker power plants.
They also talk about deep physical mobility integration.
Right, tying the house to the transportation network.
The robotic homes are purpose-built to interface directly with external autonomous networks. The text describes homes communicating with robotaxis and on-demand ride shares.
Because the home brain knows your schedule, it summons a vehicle exactly when you need to leave.
You just walk out the door and a car is waiting.
Yes. It can also automatically summon autonomous delivery bots.
The text specifically mentions Kalan-style robots.
Right, these little wheeled delivery vehicles. They dock seamlessly at specialized robotic ports, integrated into the house's exterior.
To deliver groceries directly into the zero human access utility corridor we talked about earlier.
So the fridge stocks itself without you ever seeing a delivery person.
Your personal electric vehicle charges on inductive pads built right into the garage floor. They even cite the Alliance Texas Mobility Innovation Zone as a prime testing ground for this exact type of multimodal autonomous integration.
It's like playing SimCity, but your actual physical house is constantly talking to the mayor's office and the local transit authority.
It represents a continuous closed-loop data exchange.
The city and the house are one organism.
Exactly. The anonymized data generated by the home real-time occupancy rates, microclimate information from exterior sensors, the structural health of those self-healing materials streams back to city planners.
Constantly updating.
This aggregated data is used to create what urban planners call digital twins, which are highly accurate virtual models of the physical city.
With a constantly updating digital twin, the city can execute real-time traffic routing, optimize waste collection routes based on actual generated trash, and manage water resources with incredible precision.
And public safety. The homes are designed to act as decentralized first responders.
Which is both amazing and a little terrifying.
In an emergency, the home brain can automatically unlock specific exterior doors for municipal drone access, share live internal video feeds with municipal command centers, and coordinate neighborhood-wide evacuations through the integrated displays and audio systems.
The AI is constantly monitoring the environment.
So if it smells smoke?
If the sensors detect poor exterior air quality from a wildfire, it seals the house and scrubs the air.
Wow.
If it detects an intruder, it locks down the perimeter. If the acoustic or thermal sensors in the floor trigger a fall detection alert for an elderly resident, the house autonomously assesses the severity and alerts the city's emergency infrastructure.
Providing paramedics with the exact location and vitals before they even arrive.
It could save countless lives.
Okay, I am officially sounding the privacy alarm right now.
I was waiting for this.
This is where the utopian vision gets incredibly dystopian for me.
Still a lot of surveillance.
I have 12 robots tracking my every physical movement. My kitchen appliances know exactly what I eat and when. My floors know my gait and when I fall.
They know your exact biological rhythms.
And my house is continuously streaming this anonymized occupancy data and potentially live video feeds to the city grid and a corporate AI.
That's the deal you make.
At what point does a robot-optimized home just mean the ultimate corporate surveillance state?
It's a very fine line.
Who truly owns that data? And how anonymized can it really be if the system knows I am specifically having a heart attack in my specific living room?
If we connect this to the bigger picture, you are hitting on the central, unavoidable societal trade-off that the prospectus is proposing.
It's a massive trade-off.
They're offering you hyper-efficiency and unparalleled convenience. You get a house that fixes its own roof, buys your groceries, acts as your private security detail, and potentially eliminates your utility bills by autonomously trading its own solar power.
Which sounds like paradise.
But the currency you pay with, above and beyond the $299 monthly subscription, is becoming a permanent, transparent data node.
You give up all privacy.
You are fully integrated into the corporate and municipal grid.
Which brings up the public-private partnership angle. The text heavily highlights that the founders believe municipal governments will actually become the company's biggest evangelists.
They think mayors will be begging for these homes.
Why? Why would a city mayor champion a private tech startup taking over the housing sector?
Because these homes help municipalities effortlessly hit their 2030 ESG targets, their environmental, social, and governance goals.
Ah, the climate goals.
Because the houses are carbon negative, they don't produce waste, and they reduce the strain on the aging public power grid.
They solve the mayor's biggest headaches.
Precisely. From a city planner's perspective, they get an instantly green, highly predictable infrastructure node that shifts the immense burden of civic maintenance, emergency monitoring, and energy management from the underfunded public sector to this highly capitalized private AI platform.
To prove that this level of integration isn't just some wild theoretical Texas experiment, the prospectus singles out a very specific global target for their Phase 3 expansion.
Right. They look overseas,
They explicitly target Singapore.
which is a fascinating choice.
Why is this tiny, highly developed island nation the key to unlocking their trillion-dollar valuation?
Because Singapore represents the ultimate regulatory, infrastructural, and cultural stress test for this entire concept.
It's the ultimate proving ground.
The text deeply analyzes Singapore's Smart Nation 2.0 initiative, which the government launched in October 2024.
What's the goal of that initiative?
That initiative was built around a specific framework focused on trust, growth, and community. Looking forward to their 2026 budget, Singapore is explicitly targeting becoming an AI nation.
They want AI integrated into everything.
However, as it currently stands, Singapore's smart features are largely focused on top-down public infrastructure.
Like smart traffic lights and stuff.
Exactly. They have sensors embedded in their HDB public housing blocks to monitor elevator health. They have digital districts like Punggol. They use AI to manage public waterways and traffic density.
So it's all happening at the macro, public level.
Yes, the government runs the smart systems, but the inside of the citizen's apartment is still just a regular, dumb apartment.
GlobalProp AI is positioning itself to be the private sector last mile that completes that vision.
Right. They want to connect the smart city to the smart living room.
Singapore already has autonomous mobile robots, or AMRs, roaming the public streets for package delivery and civic maintenance.
They are everywhere.
GlobalProp's pitch to the Singaporean government is essentially, you have built the smart streets and the public AMRs. We will provide the highly advanced, standardized robotic homes that your public AMRs can actually dock with and communicate with.
It's a perfect handshake between public and private robotics.
They also address a massive geographic constraint that makes Singapore unique: severe land scarcity.
They can't just build outward like in Texas.
Right, because they are an island, they have to maximize every single inch, and they rely heavily on design for manufacturing and assembly, or DFMA.
Which is basically prefabrication.
Yes, this is a process where buildings are assembled from prefabricated modules to reduce reliance on on-site construction labor.
Which Singapore relies heavily on foreign labor for, so reducing that is a big goal.
GlobalProp's core pitch, a 1,500 square foot prefabricated footprint that functionally acts like a 3,000 square foot home because of the moving walls and zero wasted space, is absolutely tailor-made for a spatial crunch like Singapore.
It essentially doubles their usable housing density without building taller skyscrapers.
Furthermore, the data exchange becomes deeply symbiotic. Singapore desperately wants verifiable ESG data to align with their ambitious green plan. GlobalProp's homes take the passive public sensors that Singapore already has and turns them into an active, localized robotic ecosystem.
And because the home's energy trading and maintenance logs are recorded on a blockchain ledger, it generates mathematically verifiable ESG data.
That the government can use to prove they are hitting their climate targets.
It's like Singapore spent a decade building the world's most advanced civic operating system.
And GlobalProp AI is pitching themselves as the killer consumer app that finally makes the OS useful and interactive down to the level of the individual citizen.
That's a perfect way to phrase it.
But I have a major, glaring structural question here.
Let's hear it.
Over 80% of Singapore's resident population lives in government-built HDB flats.
It is one of the most successful, highly centralized public housing programs in the entire world.
Exactly. So a hyper-capitalist, fractionalized, blockchain tokenized, private crypto startup really going to integrate smoothly into a highly centralized, government-led housing system.
It seems like oil and water.
The cultural and economic clash between those two ideologies seems immense.
That potential clash is exactly why targeting Singapore is either a stroke of absolute strategic brilliance or a display of massive tech founder hubris.
It could blow up in their faces.
It is the ultimate crucible. If GlobalProp can navigate that highly structured environment, if their internal robots, their self-healing mycelium walls, and their blockchain-based power trading algorithms can satisfy Singapore's notoriously strict regulatory codes
Their uncompromising security standards.
and their rigid urban planning boards, then the platform is instantly and globally validated.
Because if it works there, it works anywhere.
The argument to investors is simple. If this deeply complex private AI ecosystem can seamlessly integrate into the highly managed state infrastructure of Singapore, it can be exported to literally any other city on the planet.
We have covered a truly staggering amount of ground today.
It's a lot to process.
We started by looking at a single 1,500 square foot room with walls that glide on tracks and appliances you aren't allowed to touch.
The zero human access lifestyle.
We explored the deep science of self-healing polymer veins and dormant bacteria that allow a foundation to sweat limestone.
The biological construction phase.
We tracked the gigafactory math and the sauce multiples meant to turn this 3D printing startup into a $1 trillion global empire.
The venture capital pitch.
And finally, we saw how these homes are explicitly designed to act as the atomic building blocks, plugging directly into the digital grids of the most advanced cities on Earth.
It is a breathtaking, almost dizzying vision of technological convergence.
Convergence is the perfect word.
We are looking at advanced artificial intelligence, next-generation material science, autonomous robotics, and blockchain tokenization, all maturing and colliding in the residential real estate market at the exact same moment.
And this brings the entire deep dive right back to you, the listener.
Why should you care?
Exactly.
Yeah.
Even if you do not work in real estate or robotics or venture capital, I challenge you to consider this level of technological convergence in your own field.
It's coming for every industry.
When 4 or 5 bleeding-edge technologies mature simultaneously and intersect, it doesn't just incrementally improve an industry, it entirely redefines the core product.
It rewrites the rules.
How might this kind of simultaneous multidisciplinary disruption rewrite the rules of whatever you do every single day?
And I will leave you with one final, lingering question to mull over as you go about your day.
A philosophical thought.
We have spent the last hour meticulously discussing the engineering mechanics and the trillion-dollar economics. But consider the deeper philosophy of this transition.
Okay.
If you live in a physical structure that autonomously repairs its own walls, that buys and cooks your groceries without asking, that acts as a decentralized first responder for the municipal government,
That generates and day trades its own electrical power.
and is fractionally owned by anonymous investors trading digital tokens on a global blockchain.
Do you actually own a home anymore?
Exactly. Or have we simply evolved into paying a monthly subscription to inhabit a highly optimized physical algorithm?
That is an incredibly heavy thought. We have gone from the static, decaying wooden box to living inside an algorithm.
A literal machine for living.
Thank you so much for joining us on this deep dive. Keep asking questions and keep exploring these futuristic edge cases with us. We will see you next time.